All right, thank you so much for joining us today. And in this video, we have 10 questions that we are going to go through together. And I know you are going to enjoy it. Let's start. So we have this question where we have marginal profit, and then we have the P of this one. So they've given us the information. So all we just need to do is we need to look for F of P of 43. So let's use the approximation. P of 43 is approximately going to be equal to P of 40 plus P prime of 40, then 43 minus 40. So this one is like we are finding the equation of the tangent line where we have f of x minus f of x1, which is equal to the slope, which is f prime of x, and then x minus x1. So kind of we are trying to do something like this. So here is where x is equal to 43, right? And then x1 is 40. So here will be 40, and here will be 43, and here will be 40. So that's what we just did here. But the only thing is I moved this one to the right, and then I had to be positive. So 43 is equal to, when I move this one, become 40. So P of 40 plus f prime of 40, which is the same as the P prime of 40, and then 43 minus 40. So that is what basically we are doing here. So all the information is given. So we are going to have 600 plus 4. Then when I multiply this, I'm going to have it to be 3. So 600 plus 12. And then this is going to give us a big 612. So basically, this is how it's supposed to be. It's very simple. Know the trend, know how it goes, and you'll be fine. Right? Yeah. Good. So that is the first question, question one. Let's look at question two. So given the price demand equation, which is this, and then the cost function, which is this, we need to find revenue. So revenue is equal to quantity times price. So as I said, always check what is here. If this one is X, then it means that we need to get away with the P. If this one is P, then we need to get away with the X. So sorry, if this one is, yeah, that's right. So now since this is X, we need to look for P. But fortunate for us, P is given here. So we are going to have this to be equal to X times 800 minus 4X. And when I multiply through, I'm going to have 800X minus 4X squared. So this will be my revenue, right? So nice. Now let's look at the profit. So we've been doing this, I think, quite often. So you should be able to remember the formulas. So profit is revenue minus cost. So what is the revenue? Revenue is what we just found here. So this is going to give us 800x minus 4x squared minus cost. Cost is given. So we are going to have 6x plus 100. Let's simplify that. 800x minus 4x squared minus 6x plus minus 100, and we are going to have minus 4x squared minus plus 794x minus 100. So when I subtract this from this, I'll get this, which is right. So this will be the profit function. Let's look at the marginal revenue function. So the marginal revenue function, since we are talking about revenue, then it means that we need to differentiate the revenue function here. So we know that revenue is equal to 800 minus 4x squared. 800 squared x. So that was the revenue, 800x minus 4x squared. So let's do the differentiation, which will give us the marginal revenue. So I'm going to have r prime of x to be equal to 800 minus 8x. That will be the marginal revenue. Now use the marginal revenue function this to estimate the change in revenue resulting from producing the 51st item. So since we are using this estimation and this is going with 51st, it means that here our x should be equal to 51st. So 51 minus 1, and this one should be 50 because this is 51st. If this one x was given like 51, then we use that one. But since we have 51st, we need to subtract 1 and we get 50. So it means that r prime of 50 is going to give us 800 minus 8 times 50, and this is going to give us 800 minus 8 times 5 is 40, so we are going to have 400, and this is going to give us a big 400. So always check, as I said, check what your function is in terms of. So this is x, so my final result should be in terms of x. This is x, the same thing happens here. This one too is the same thing here. And then we're able to find this, estimate that. Okay, so this is end of question 2. Let's go to 3. Now we want to find the critical values, right? So let's do that. So for us to find the critical value, first thing that we need to do is we need to differentiate the function. So f prime of x will be equal to, let's do the differentiation using power rule. So this is going to give us 6x squared minus 6x minus 12. This is interesting. So I factor 6 out and I have x squared minus x minus 2. So let's try and factor them out. So I need two values. When I multiply, I'll have negative 2, but when I add, I'm going to have this. So this is the same as x squared minus 2x plus x minus 2. And guess what? This is going to be 6x x out, x minus 2, and this will be 1 x minus 2. So I'm going to have 6, and I'm going to have x minus 2. So when I factor x minus 2, it will be left with x plus 1. And I'm going to have x plus 1. Right, so this one is not difficult for us to see that when x is equal to 2, it will be 0. And when x is equal to minus 1, that one too to be 0. Or you can just pick this one and set it to 0, like 6x minus 2, x plus 1 is equal to 0. So first, I'll divide through by 6 because this 6 here is not with x. So when I divide through by x, 6, I'll have this, that is equal to 0. So x minus 2 is equal to 0, x is equal to 2, x plus 1 is equal to 0, and x is equal to negative 1, which confirms what we have here. So this is the critical value, right? But basically, we want to look at B and C. We want to state which x value or values is having the maximum, that is the local maximum and the local minimum. So it means that what we just need to do is we need to continue from here by using the sign chart. So let's draw our sign chart. So this is our sign chart. We have negative 1, we have 2. And you know that as soon as you get the critical value wrong, it means that this and this is going to be wrong because anything that you're going to do here is wrong. So for example, this one's supposed to be 1 and I'm making it, let's say 1, and this minus 2, it means that automatically I'm getting everything wrong. Don't forget, with local maximum and minimum, we use f prime of x. So what we are going to do is, don't forget this is f prime of x. So we are going to pick any value before negative 1. So we can pick negative 2. In between negative 1 and 2, we can pick 0, right? And then after 2, we can pick 3. So we want to check whether it is greater than 0 or less than 0, positive or negative. So let's plug in minus 2 inside this. When I plug in minus 2 here, minus 2 minus 2 will be minus 4. So here is negative. When I plug in minus 2 here, minus 2 plus 1 is also negative. So negative will be positive. So it means that this one will be greater than 0. So this one is positive and this one should increase. Plug in 0. 0 here will be negative. So this one will be 0 minus 2 and to be negative. 0 plus 1 will be positive. And when I multiply positive and negative, I'm going to have negative. So this one will be less than 0. So I'm having minus and this guy is coming down. Let's look at the last one, 3. 3 here will be positive. 3 here will be positive. So positive is positive. So I'm going to have this one to be greater than 0. And this one will be positive and this one will be going up. So it's quite interesting to see positive, negative. So when I see positive, negative, then I know that there will be a maximum. So you can see that here at -1 and there will be a minimum at 2. So the x value here is a big, this one is a maximum, right? So a big X is equal to -1 and the minimum will be a big X which is equal to 2. So that will be what we need to get from here, because this is at -1 is where we have the maximum and at 2 is where we have the minimum. So this is local maximum and this is local minimum. Good. Let's look at question 4. So we are saving money to purchase for a large purchase worth 90,000. So we take this one and we are putting into savings account and the interest is compounded continuously. So this is very important. So how many years? So how many years mean that we are looking for T, right? And then the account is going to reach this. Okay, so the question is saying that it does not add any money into the account after the initial deposit. Okay, so this word here is telling us that we are going to use the formula A is equal to P e to the power RT because this is compounded continuously. Now, what is A? A is the amount that we are going to get after so many years or after some years. So after some years, we are going to have 90,000. So A is equal to 90,000. So this is our A. Now, what is the initial deposit? Initial deposit is the P. So we deposited 30,000 into the savings account. So our P will be equal to 30,000. And we are earning interest of 4%. So interest, which is R, is 0.04. So we know A, we know P, we know R. So we need to find for T how many years. So that's what we need to do. So let's just do substitution. This will be 90,000, which is equal to 30,000 e to the power 0.04 T. So I just did substitution. This is equal to this. This is equal to this. R is equal to this. So what I'm going to do is I'm going to divide this one by 30,000, divide this one by 30,000. So 90,000 divided by 30,000, 30,000 divided by 30,000, 0.04 T. So the magic happens. This will cancel this. These zeros will cancel these zeros. And 3 goes here 1 and goes here 3. So I'm going to have 3 to be equal to e to the power 0.04 T. Now, since we have an exponential function here, we need to think about the natural log, right? So I'm going to take natural log on both sides. So I'm going to have this e to the power 0.04 T. Then this here is going to give, since I have the natural log and e, this will be equal to what is on the top. So I'm going to have ln of 3 is equal to 0.04 T. And since I'm finding for T, I'll divide this one by 0.04 divide this one by 0.04. So guess what you are going to get? You are going to have t to be equal to the natural log of 3 divided by 0.04. We are not using calculators, so we can decide to stop here. So this is the number of years that we need to put the money, which is 30,000, to reach this amount. All right, let's look at question 5. Find the derivative of the following functions. So this is a polynomial function, so we don't need to do any simplification. So what will be y prime or dy over dx? Using the power rule, 11 will multiply 7, which is going to give us 7, 7. Then subtract 1, so reduce to 10. 6 will multiply the 5, giving us 3, 0. Reduce it by 1, and we get 5. Then when I differentiate x, I'm going to have 1, so I'll have plus 4. When I differentiate the constant, I'll get 0. So this is y prime or dy over dx. Any of them works. Let's look at b. So b, we have two functions. So what we need to think about is we need to think about a function like a and b. So I choose my a to be equal to, let's say, x to the power 4, and my b to be equal to e to the power 6x. What is a prime? A prime is equal to 4x to the power 3. What is b prime? B prime is 6 e to the power 6x. So power rule here, and this one, when I want to differentiate this, I maintain the function, then I multiply it by the derivative of what is on the top. So this is what I'm going to get. So what will be y prime? Y prime is equal to a prime b plus a b prime. So you see that if a is prime, b is not prime. If a is not prime, b is prime. So that's the formula for finding the product rule. So this is going to be, we know a prime to be this, we know b, we know a to be this, and we know b prime too. So let's do substitution. So a prime is 4x to the power 3, then b is e to the power 6x, plus a is x to the power 4, and b prime is times 6 e to the power 6x. Small simplification and we are done. 4x to the power 3 e to the power 6x plus 6 x to the power 4 e to the power 6x. So this is the product rule for this function right here. So it's always good to pick this and then you just do substitution. You can also do direct differentiation and you're okay to go. Now let's look at this. We want to differentiate this, and what can we do? So to differentiate this function, we can see that this function here is actually this over this. So we can think of the quotient rule. So quotient rule, let's name this one to be u divided by vn, right? So we know u will be equal to x, and vn will be equal to x to the power 3 minus 5. So we need u prime, and it is 1, and we need v prime, which is equal to 3x squared. Very simple. So now what is y prime? Using the quotient rule, then u prime minus minus v prime u divided by v squared. So I maintain v. This is not symmetric. If this one is positive, then I can swap this and that. But because of the minus, always maintain v first. With the product rule, I can decide to swap this and that because it's positive. But this one, always maintain v first. So this is the formula. Now let's do substitution. What is v? V is this. So x to the power 3 minus 5. U prime is 1 here. Minus v prime is 3x squared, which is here, times u, which is x. So x. divided by v squared minus 5 all squared. So what are we going to get? If we want to simplify, we are going to have x to the power 3 minus 5 minus 3x squared divided by x to the power 3 minus 5 all squared. Can just leave it this form because we cannot do any further simplification, and then we are done. So this is 5. Let's look at 5D. Now 5D here, we are going to use the change rule, right? We are going to use the change rule. So let's do direct change rule, right? So this is going to give us y prime is going to be, now apply the power rule. Assuming nothing is here, so power rule will drop the 10, then x, then of x, then I subtract 1, 9, times, now I differentiate what is inside the parentheses. So x to the power 3 plus then of x. So I just apply the power rule. I just drop the 10, maintain everything here, and subtract 1. So I have this times, now I differentiate what is inside the parentheses without this. So I'm going to have 10 x to the power 3 plus this to the power 9 times, and when I differentiate x to the power 3, I have 3x squared plus, when I differentiate a length function, I get 1 divided by x. I can leave my answer in this form. I don't want any trouble, so I'm not going to simplify anything. I just leave my final results here. Good. Let's look at E. Now with E, we need to do some simplification before we can differentiate. So we can say that y is equal to 4x to the power negative 2 minus 6x to the power 1 over 2. So this is kind of nice. So what will be y prime? This is going to be 2 will multiply this. So we are going to have negative 8. Then I subtract 1, so negative 3 minus 6 times 1 over 2, then 1 over 2 minus 1. So this is going to give us minus 8x to the power minus 3. This time this is going to give us minus 3, and then this minus that is going to give us minus 1 over 2. I leave my final results here. I can decide not to simplify. If you want to do further simplification, you can do that too as well. Let's do the last question on D. Now y prime is equal to, we know how to differentiate a length function, 1 divided by what is inside the parentheses, or times the derivative of what is inside the parentheses. So this is going to be 1 over x to the power 7 times, I differentiate this and I have 7x to the power 6. Now I can write this one as 7x to the power 6 divided by that. But we can see that this is 6x and we have 6 of the 7, like 7 of them. So when I cancel it out, I'm going to have 7 divided by x. So this is 7 of them, this is 6 of them. So I'll cancel and to be left with just 1. So this will be the derivative for this. So this is the end of question 5. Let's look at question 6. So this is the implicit differentiation. So you see the way, when I see the question, I know the rule, I know which one to use. That's what you need to do. Always when you see the question, okay, which question is this, right? So we see that this is the implicit differentiation. So I need to find dy over dx at this point. So we are differentiating this with respect to what? X. So I'm going to differentiate both sides of the function x squared plus 4x plus y to the power 3 minus y with respect to x. So let's go. Remember, we are going with respect to x. So when I differentiate x squared, I'll have 2x without adding anything to it, because if I'm adding d of the x divided by this, I'll get 1. Then when I differentiate 4x, I get 4, because when I differentiate x, I'm going to get 1. Now, the problem is here. When I differentiate this, it's like you are differentiating x to the power 3. So this is going to be 3y squared, but this one will multiply by dy over dx because this is not 1. So when you are done with this one, 3x squared, then d of the function here, y, divided by this. So d of y divided by that. This one, we had d of x divided by this, and it is 1. So we had this. This one too, d of x divided by dx is also 1. Now here, when I differentiate y, you know that I get dy over dx. And when I differentiate a constant, I get a big 0. So let's try and simplify. Or even you have a point. We have a point 2 and 0. So this is x and this is y. So let's try and put them inside. So let me shift this one here. I'm going to have 2 times 2 plus 4 plus 3 times 0 squared dy over dx minus dy over dx is equal to 0. Now since this one is 0, this one goes to 0 because 0 squared is 0 times 3 is 0, 0 times this one is 0, so it goes to 0. So I'm going to have 4 plus 4 minus dy over dx, and this is 0. Now I'll move this guy to this. So since it's minus, it becomes positive. This and this is going to be 8. So I'm going to have 8 is equal to dy over dx. And then if I want to write the y over dx first, then I'm going to have a big dy over dx, which is equal to a big 8. So the slope or the dy over dx is equal to 8. Good. Let's look at B. Find the equation of the line tangent to the curve at 2 and 0 in the slope intercept form. So when I say in the slope intercept form, this is what we are talking about. Y is equal to mx plus c. So when you are done solving, what you need to do is simplify it in a way that you get this. Right? So what's the equation of the tangent? Y minus y1 is equal to the slope x minus x1. Now remember, this point here is x1, this point here is y1. So I have y is equal to 0, y minus 0, which is equal to m x minus 2. So this is not difficult to see that y is equal to m x minus 2. But what is m? Know that m, which is the slope, is the same as dy over the x, and that's what we were working so hard in 6a, and we had 8. So this is equal to a big 8. So we plug it in and we have y is equal to 8 x minus 2, and we need to simplify it so that we get it in this form. So we are going to have y is equal to 8x minus 16. So you can see that m is 8, which is the slope, and then minus 16 is the c, which is the y-intercept. So this is how we need to leave the final results to be this, so that we get the 4 marks. Question 7. So we have 10 questions. 7, 8, 9, 10. We are almost there. So let's look at this. Here we want to find the revenue function. Always think of this is in terms of x. Okay, so now my revenue is equal to x times price. So since this is in terms of x, I need to look for price. Okay, price is given. So this is x times 700 minus x multiplied through by x, and you have 700x minus x squared. Very nice. So that is revenue. Very simple to do that. Now, if demand is increasing, now don't forget here demand is x. The demand is x. So don't forget. So if demand is increasing at a rate per week, so it means that increasing means that it's positive, and rate means that we have change in x divided by, change in x over change in t. What that is the x over the t to be equal to 2. because this is the rate, and increasing means that this is positive. When it's decreased, it means that this will be negative. And then when demand is 100 units, mean that x is equal to 100. The question is, what is the value of the derivative of the revenue? So what is the revenue? We found out that the revenue is equal to 700 x minus x squared. So since now we are looking for the derivative, we are looking for the r over the t. So remember here, we are differentiating this with in terms of a function which is not in this. It is not r, it is not x. So when I differentiate 700x, when I differentiate x, what am I going to get? I'll have 700 the x over the t, because we are differentiating it with respect to t. Minus when I differentiate x squared, I'm going to have 2x dx over dt, because we are differentiating it with respect to t. So when you do the normal differentiation, when I differentiate x squared, I get 2x, but I need to multiply by dx over dt. The same thing to this one too. So I know x, I know dx over dt. So I'm going to have 700 times 2 minus 2 times 100 times 2. So I'm going to have a big 1400 minus a big 400. And this is going to give us a big 1000. Good. So the change in revenue is 1000. Good. So this is the end of question 7. We are almost there. Question 8. Oh, I like these questions. I like this one. Elasticity. So we want to find the elasticity, right? So remember this one, the formula is already given to us. So the general elasticity is equal to this. So it means that E of P is equal to minus P F prime of P divided by F of P. I love this question. Now all I need is, I know that F of P is this. I have P here because the function in terms of P. So all I need to look for is F prime of P. So let's differentiate this. And this is kind of very simple. So F prime of P is equal to -3. Wow, just -3? Because I differentiate this one will be 0. When I differentiate P, I get 1. So just left with -3. So let's try and then do substitution. So this is going to be minus P times this is equal to -3. So I'll put it in the parentheses nicely. Divided by this, which is this. So I'm going to have 600 minus 3x, and minus will be positive, so I'm going to have 3p divided by 600 minus 3p. Don't try to simplify. This is okay, just leave it here. Don't cancel this and this. This is not true. Don't cancel this and this. This is not true. Just leave it in this form. We can simplify it, but this is okay. Just leave it in that form and you are okay to go. Find the elasticity when price is 50. So here we are finding for E of 50. So let's plug E of 50 inside this, which is this. So we are going to have 3 times 50 divided by 600 minus 3 times 50. So 3 times 50 is going to be 150. 600 minus 150. And then this is going to be 150. When I subtract 150 from this, this should be, I think, 450. Is that right? Yes, I think so. Then 0 will cancel 0. 5 goes here, 3 goes here, 9. 3 goes here, 1, and goes here, 3. So the final results here should be a big 1 over 3. Nice. So we can see that this is like inelastic because it is less than 1, right? For what value of P does an increase in price results in an increase in revenue? So this one is inelastic, right? Because increase in price, increase in revenue. So inelastic is when E of P is less than 1. So we want to look for the values of P. So meaning that we need to go and look for this. This was equal to this. So let's replace it by that. So it is equal to 3P 600 minus 3P less than 1. Now let's find for P. This is over 1. So this will multiply this and this will multiply that. So I'm going to have 3P less than 600 minus 3P. What I'm going to do is I'll move this to this side. And when I move this one, since it is negative, it becomes positive. So I'll have 3P plus 3P less than 600. And I'll have 6P less than 600. Let's divide through by 6. Divide through by 6. And guess what? P should be less than 100. So all the price that are less than 100 is going to give us an increase in price, an increase in revenue, inelastic. So this is what you are going to get for the C. Good. 2 more to go. Let's look at the question 9. Question 9 again, we need to find critical values. So we need to find G prime, but G prime we need to use the product rule. So U A B, right? Let's assume that A is equal to x to the power 4 and B is equal to EX. What is A prime? Using the power rule, we get 4x to the power 3. What is B prime? When I differentiate EX, I get EX. So what is G prime? G prime is equal to A B prime plus B A prime B. So this is going to give us A is x to the power 4, B prime is EX. So this is A, this is B prime. Plus A prime is 4x to the power 3 times B is e to the power x. So let's try and simplify because that is what is important here. So I can factor x to the power 3 out because I can also see x to the power 3 here. I can also factor e out. So I'm going to factor x to the power 3 ex. What will be left here? So when I factor this one out, it will be left with x to the power 4. And when I factor this one out, it will be left with just x. And then when I factor x to the power 3 and this one out, it will be left with just 4. So plus 4. So anytime you have a function like this, don't look at this guy, okay? Don't mind this guy here, okay? Just mind this guy and this guy. So this is, we are picking when x is equal to 0, you will see that this will go to 0 because when I put 0 here, boom, 0. When x is minus 4, this one too, boom, 0. But you can also see it this way. X to the power 3 e to the power x, x plus 4 should be equal to 0, right? Now this cannot go to 0, so I can divide through by e to the power x, e to the power x, and I'm assuming that that one will just go. So I'm going to have x to the power 3, x plus 4 is equal to 0. We note that this is not 0, so that one will just take out. Then x to the power 3 is equal to 0, so x should be equal to 0. X plus 4 should be equal to 0, so x should be equal to minus 4. So that's another way of figuring out if x is equal to 0 or x is equal to minus 4. Okay, so these are the critical values that we have. So let me just put them here. Now, basically, we are going to talk about local minimum and then local maximum, right? So minimum and maximum. So we need our sign chart. Okay, so it means I can even look it here. So let's talk about sign chart. Nice. So let me put minus 4 here and let me put 0 here. Don't forget, we are using G prime of x. What was G prime of x? x to the power 3 e to the power x, x plus 4. So pick any value before -4. So -5. Any value here is -1, and any value here is 1. So let's plug in -5. When we're doing that, don't think about this. Just think about this guy and this guy. Now, when I plug in minus in this, since this one is odd, it will be going to be negative. So you can use calculator to check. This one will be negative. When I plug in -5 plus 4, this one too will be negative. Negative will be positive. So this guy will be greater than 0, and we have positive, and we can see an increase. Let's plug in -1. As I said, negative, since this one is odd, still this one is going to be negative. -1 plus 4 is 3. So positive, negative is going to be negative. So this is less than 0, minus, and this one is going to decrease. Plug in 1. Everything is going to be positive because 1, 5, 1. So this is going to be greater than 0, and this is positive, and this is boom, increasing. So we can see maximum at this side, and we can see minimum at this side. So let's talk about local max. Is at when x is equal to -4, and let's talk about local minimum. This one is at x is equal to 0. So sign chart is very useful, but the most important thing here is how to find the derivative and how to find your critical values. They are the most important thing that we need to consider here. I think it's left to the last question. Are you ready for the last question? Yes. Okay, so this is the last question that we want to do. Suppose the demand function or the demand equation is this. So let me write the demand equation down. X squared plus xp plus p squared is equal to 39, where x is quantity and p is price. If price is increasing at a rate, so increasing means that it's going to be positive, at a rate means that there is a change. So since we are talking about price and price is p, we are going to have information like the p over the t to be equal to 3 because it's increasing and we have rate. When price is 5, so p is equal to 5, and demand, now demand is x and demand is equal to 2. Find the rate at which demand is changing. So what we are looking for is we are looking for the x over the t. So this is what we are looking for. So we can get this from that. So now let's differentiate this function here. So don't forget we are differentiating the function, all of them with respect to t. Good. So when I differentiate x squared, what am I going to get? 2x, but since this one is not x, I'm going to add the x over the t. Interesting. Plus, I have two functions here, x and p, so I need to use the product rule, right? So if a is equal to x and b is equal to p, what is a prime? When I differentiate x, I get 1, but since we are differentiating with respect to t, I'm going to have the x over the t. Interesting. B prime is also this. I'm differentiating this p, I'm going to get 1, but since we are going with respect to t, this is also going to be the p over the t. So this times that, and then this times that. So in the end, we are going to have plus x dp over the t with a red, and then plus p dx over the t with the green, right? So that's the product rule. Or if you want to do it direct, maintain x, differentiate p, plus now maintain p and differentiate x, plus now when I differentiate p squared, I'm going to have 2p dp over dt, and the magic happens here. When I differentiate a constant, I get a big zero. So now dp over dt is given, p is also given, x is given. So we can now do direct substitution. So what is x? X is 2. So in place of this, I have 2 here. Then I don't know the x over the t. Actually, that's what I'm looking for. And then x is 2. The p over the t is 3. So I'm going to have 2 times 3 plus p is 5. But I'm looking for the t, the x over the t. So I can't get that one too. 2 times p is 5. And the p over the t is 3. So I'm going to have times 3. This is equal to 0. Let's finish it up. So this is going to give us 4 dx over dt plus 6 plus 5 dx over dt, 10. This is going to give us 30. 3 0 is equal to 0. So what are we doing? Let's group like terms. So 4 dx over dt plus 5 dx over dt is going to give us 9 dx over dt. Then this plus this is going to give us plus 36 is equal to 0. So 9 dx over dt is equal to minus 36. Divide 2 by 9. So I'm dividing this one by 9, dividing this one by 9. And I'm going to have a big ds over a big dt to be equal to. Now, I think 3 goes here, 3. And then 3 goes here, 12. Is that right? Yes, 3 times 12 is 36. And then 3 goes here, 1, and goes here, 4. Oh, not too surprising. This is supposed to be negative 4. So this is what we are going to get at the end of the day, a big one. So this is our final results in the final video. So this is what we are getting. So this is exam 2 spring 2025. It means that this is the one that we just did this semester, right? So what we just need to do is, if we have watched the exam 1, if we have not done that, go and watch it and then watch exam 2. So it means that in the next video, I'm going to talk about exam 3 spring 2025. Don't forget, this is the roadmap to final exam. See you in the next video.